Hey everyone! In this video, I'm going to go through a quick coding example focused on this question of data and measurement and how we can use graphical tools to kind of explore measurement properties and ultimately kind of answer questions related to where our data is coming from and what it can actually tell us about our concepts of interest, for example, right? And so this specific example is in the book Regression and Other Stories, and it's based on a graphic that went viral on the internet a couple of years ago, and specifically it is a map that compares the 50 states, United States, in terms of their human development index, which is usually used to compare different countries in public health measures globally, right? And so this graphic kind of showed quite stark differences in this human development index and thereby kind of caught some attention online, okay? And so the underlying question is, of course, to what extent do these differences in the human development index actually tell us something about the living conditions of people in these states in the US, or to what extent are they an artifact of some other some other underlying factor? Okay, and we're gonna do two things. First, we're going to kind of replicate this map, and I'm going to show you how to create a map of the Human Development Index in the U.S. But also, what we're going to do is then explore a little bit of where this variation is coming from, and to what extent is this variation actually, informative for people's living conditions, right? So let's jump right in. The first thing we're going to do is, again, we're going to look at the raw data. Again, these data will be available on our Studio Cloud. And you can explore these data directly with me as you watch this video. There are two data sets. And this is quite nice as kind of an exercise because it also involves us kind of merging data sets and combining them in one data frame right away. So the first data frame that we have here is a .dat, which is just a text-based data file that we are going to read in using the read.table command. We include this option header equals true because the first line of this text file contains the variable names. We then again use our piping operator and then convert this to a tibble because we want to because the tibble ultimately provides nice printing options and so on compared to a standard data frame, and that's kind of the standard data frame format that I'm going to use throughout our examples. Then we will select, we will remove one variable, which is the distance to Canada, which is in that data frame as well. So it's the number of states that you have to drive through in order to reach Canada, which we don't need for this example. So we're just gonna remove it, and then we will mutate. We will recode or create a new variable called region, which is based on the original state variable. And the reason why we are creating this recoded region variable is because we will use that region variable to ultimately merge our data frames together, right? And so the way merging works is that ideally, usually you have two different data frames, right, with different observations, or with corresponding observations, I should say, and they need some common identifier. And this common identifier in this case is this region variable. So both data frames will have the region variable included. But as you can see, the state variable, the original state variable, is just the name of the state. And it turns out in the other data frame that we're going to merge, these state names are saved in a slightly different format. They are all lowercase. And in addition, Washington, D.C. is just saved as Washington. So So in order to kind of make this work, we have to do two quick things. We have to first turn this to lowercase, and then remove the DC from Washington. Okay. I might have to check this, but I'll if there's an additional, because of Washington State, there might be an issue with the merge. But if that's the case, I will update you in the Q&A session whether there's a problem here. But for now, we have our new tibble, 51 observations, so that's all 50 states plus Washington D.C. And we have our state, we have our human development index, and we have our region variable that we just created. And I'll check back if I created a problem here with Washington and Washington DC, and if necessary, update that code accordingly. Then we have an additional data frame which we call votes. This is a data frame that contains information on the state and the average income in each state. We have a state name as well, and we have state abbreviation and so on. Some additional information. Again, the full data frame is available on RStudio Cloud, so you can check that out and take a look and look at some of the other variables that are included there as well. There's some voting information as well in case you want to kind of create some additional maps and so on. Then the next thing is we want to prepare the data to create a map, and in order to create the map, we will use the maps library. The maps library provides some additional information to ultimately plot state information or other types of maps directly in R. And we also load the map proj package, which provides additional tools for different types of projections, map projections, right? So to make them to make the map look a little bit nicer. Okay. Then the next thing we're going to do is we will use the map underscore data command to basically just create a new data frame for the US states, and that's we kind of create that or load this data frame by calling map underscore data with state as an argument. And you can see this data frame ultimately contains basically information on the precise borders in longitudes and latitudes for each individual state, and we're going to use that for plotting. You don't really have to kind of go too much into the details of how exactly this ultimately works under the hood in ggplot. All you need to kind of keep in mind is that this is ultimately graphical information on the precise borders of each state. Okay, we can just keep it that way, and then we have our state state and region information. Okay, and you see here region will ultimately be the variable that we're going to use for merging, because what we're going to do is we will use the left join command. Left join is a tidyverse merge command where we basically take the original data that is on the left, which is the map data that we kind of pipe into the left join command, and then that means we kind of keep all those observations from the first data frame from our state map data, and then we join to those observations the HDI human development index data. Okay, when we join those by the common name, which is region, and we basically keep all the original map data observations constant and just duplicate all the HDI observations as many times as necessary, and that's what is done using this left underscore join HDI. Okay, so left join means we keep all the observations in the original data, so that's the map data, and we duplicate the HDI data. Okay, if we wanted to do it the other way around, we would use right underscore join. Okay. And then again, we save this as a tibble and then look at the output, and we see now we have this longitudinal latitude, longitude, latitude information for the borders of the state. That's, we don't have to worry about that too much. The important thing is that we have the region for each state, and we have the HDI that is now merged to that information. Okay. Yes. Okay. All right. After having that, we can proceed to plot our map of the Human Development Index in the United States with using ggplot. What we're going to do is we saved our HDI map. This is the information that combines the state, their borders, and the HDI Human Development Index. And we can pass this now into ggplot with two different aesthetic mappings. We have the longitude and latitude for the underlying borders. So we'll draw the borders according to longitude and latitude. And then we have our grouping, and the filling aesthetic is HDI. So basically the color that each state will be, that each state will be colored with is depends on the value of the Human Development Index, and we'll see that in a second how that works. We then created geometry, which is a polygon, which is basically then a basically each state defined by the longitude and latitude by the grouping, and filled with the color depending on the HDI. All right, so this is kind of what draws the map and fills the map, fills each state with the color depending on the filling mapping. Size 0.1, that's the size of the border, and the gray 90 is the color of the border of each state. Okay. Then we add a map projection, Albers projection, which will look nicer than like just the standard map without any projection. We don't have to worry about those details. We also specify in order to replicate the result that is in the book, we will specify the lower limit of our color scale as white and the upper limit as black. To kind of replicate the result in the book. We add a title and a legend for the Human Development Index, and then I add some additional theme options, which you can play around as well to see what that does. Okay. And the result looks quite similar to the example that is shown in the book. We see, for example, the outlier Mississippi here with the lowest Human Development Index, and then some other countries that are extremely higher. We don't have Alaska in this map right now, but California, for example, is high. I'll have to investigate again whether I messed something up with Washington, but for the purpose of this example, this is perfectly fine. And I think that should be fine. The point is that this graphic kind of seems to suggest there's wide variability and wide variation in kind of the Human Development Index, and therefore wide variation in kind of the quality of living between these states. And the question is, to what extent does that actually accurately reflect people's living situation, right? And so in order to evaluate this, we kind of have to think about, what does the Human Development Index actually measure, right? How is it created? What does it actually capture, right? And if we look at the literature, the Human Development Index actually combines three different basic dimensions. One is life expectancy at birth. The other kind of dimension is knowledge and education, which is usually measured as the adult literacy rate, um, um, and the combined primary, secondary, and tertiary gross enrollment ratio. So kind of how many people are in what stage of education, or completed what stage of education. And then the last component, and this is key, is the standard of living as measured by the natural logarithm of the GDP per capita um, in a given state in US dollars. Okay. And so the underlying issue here, of course, is that the GDP per capita, or the overall income between these states, varies depending on, for example, Alaska, which scored very high, but of course the GDP per capita is higher because of natural resources, or if you look at Texas or California. So that doesn't necessarily mean that living conditions are necessarily different between those states, but rather they can basically just represent differences in economic conditions and economic makeup, and for example, availability of resources and so on. Okay. So in order to explore this, or kind of examine this as an alternative explanation, one thing we can do is we can look at the relationship between the Human Development Index and the average income by state. And one way to do this is to look specifically at the our votes data that we have, because that has the income data. Now we have to keep in mind that average income is slightly different than GDP per capita, so there might be some deviations, but both are obviously correlated. We can filter our votes data by looking at only the year 2000 and look at the average income in the year 2000. We then join this with the Human Development Index data to merge those together. And again, if you go through this code step by step, you can kind of just just execute this part or just run only this part first, and then run this part first, to kind of get an idea of what is actually going on and how these observations are merged. And then after we kind of merge these data frames, we can pass them on using the pipe directly to ggplot with two aesthetic mappings, one the income on the x-axis, and then the Human Development Index on the y-axis. And then we add, rather than just a scatter plot, we add text labels for each observation, where the label is determined by the state abbreviation, which was in the votes data frame. And then we add some labels. Okay. And so what is the result of that plot, of that ggplot command? That's exactly the plot that we examined, that is included in the in our book chapter as well. We see there's a clear nonlinear relationship between the Human Development Index and the average income by state. Now we can think a little bit about to what extent we should look at the logarithm of income, or the logarithm of the Human Development Index, or things like that. But the key is there is a clear correspondence, clear relationship, even if it's not linear, between the Human Development Index and the average state income in 2000. Okay. We can also, in order to kind of get rid of this nonlinearity, we can also look at the rank of the Human Development Index and the rank, the income rank by state. If we want to do this, all we have to do is to kind of switch the aesthetic mapping in our plot, rather than the raw data for income and the Human Development Index. We use the rank function for our mapping for X and Y, and then we get to the second plot that is also included in the book, and that shows there's a clear relationship in the rank between the rank of the Human Development Index and the rank of the average state income in 2000. So the argument that is made in the book is that this comparison between the Human Development Index between states in the US, at least, doesn't really represent different living conditions for people in these states, but rather represents differences in per capita income, mostly focused on economic conditions, because these other dimensions don't vary quite as much between those states, right? So that doesn't mean that the Human Development Index is not a useful measure for other types of comparisons, for example, cross-national comparisons, but at least in the case of looking at differences between states, it's mostly determined by their economic situation, per capita income, and again, that can differ, for example, also by resource availability and so on. And so it's not really informative. It doesn't really measure what initially we intended to measure, or the authors who first published this graph intended to measure, which is relative living standards, or a relative living situation, so to speak, right? And that completes our coding example. In the next video, I'm going to talk a little bit more broadly about principles of data visualization.